Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So in this video, I will show two sample hypothesis tests using Microsoft Excel. This is for subject MGT 555, chapter number 5. So for two sample hypothesis tests, right? Let's look at the description here. Many business practice or decision involve comparison of the difference between two independent population. So in this example, I will show you two type of two sample hypothesis tests. First is by using a two independent sample population, and another one is two dependent population. So we are interested in comparing two independent population parameters such as mean and proportion. Such tests can be determined the difference between two group of customer, performance of two different outlet location, properties price of two area, and other scenario. Means that we have two groups or two location in comparison. So two samples are independent if the selection of one sample from one population is not related to the selection of the second sample from the second population. Means that one population and in another one population is not related. So we are taking in two separate location or two separate group. So this is what we call as independent samples. So two samples are called as a dependent when if the member of one sample can be matched with the corresponding members in the another sample. Means that let's say for the simplest example, let's say we want in a Biggest Loser program, if you still remember. So before the participant enter to the match, they will measure the weight of the participant before enrolling to the program. After 2 months or 3 months enroll into the program, then they will take another measurement on weight based on the same participant. So this is what we call as we have a two measurement in same measurement, right? In same participant. So this is what we call as a paired or dependent sample. So formulating the two sample hypothesis tests for different independent population parameter is a population parameter 1 minus population parameter 2. So this is in hypothesis testing, we will put, let's say for null hypothesis, mu1 minus mu2 equal to 0 or equal to some numbers. So normally we will put equal to 0 to indicate whether mu1 is equal to mu2. If you do a sum manipulation, put mu2 on the left or right hand side, you will get this one lah. So we want to measure whether mu1 population parameter 1 equal to population parameter 2, right? So there are three situations or of the alternate two sample hypothesis test can be stated. This is for situation number 1, this is situation number 2, and this is situation number 3. So for situation number 1, we have 1 and 2, we have a one-tail test because we are measuring less than or more than. Right? If you are measuring less than or equal to in the null hypothesis, the alternate hypothesis will be more than. So this is going to be on the right tail. Means that if you are using you want to shade the area of the curve, it will be on the right hand side. So this is your rejection region, right? For if you have alternate hypothesis less than, it should be on the left hand side. So if you have equal sign or not equal sign on the alternative hypothesis, it will be a two-tailed test means that you're going to have two rejection region. So this is going to be your X bar. This is the first rejection region and this is the second rejection region. Both sided are rejection region. So this is going to be our own our whole alpha. This is a shared alpha. So alpha divided by 2, alpha divided by 2. Right. So let's look at the two sample hypothesis tests using Excel. If you have two sample tests for mean, right, so we're going to use z-test, two sample for mean. If you have two sample tests for mean and assume variance are unequal, so we're going to use t-test assuming unequal variance. For two sample t-tests for mean, assume variance are equal. So this is going to be a t-test 2 sample assuming equal variance. If you have a paired sample or dependent sample, so we're going to use t-test for paired 2 sample for mean. If you have more than 2 sample, let's say you have 3 groups or 4 groups, so you're going to use f-test, which is the test for equality of variance. Means that we're going to use one-way analysis of variance. So this is what we call when we have more than 2 sample variance, right? So this is the same concept but a different approach of statistics. Let's look at example number 4. So in example number 4, so the purchase order transaction with lead time data. So this data set can be obtained in a U future under discussion topic, right? So this is the data, purchase order transaction with lead time, right? So now in this file shows the order placed by the customer, order data placed by customer and received date by customer. So we are going to measure two variables here. First is order place and then one is receive date by customer. So the lead time is the time difference can be calculated as lead time is equal to arrival time minus order time. So we are going to use a lead time as our measurement. So the sales manager received a complaint from LED technology. So we're going to highlight it in a different color. LED technologies, and that his lead time is longer than his competitor SKS Enterprise. So means that the complaint here will be the alternative hypothesis, the null hypothesis will be mu for LED is equal to mu SKS. So the alternative hypothesis is we want to know mu for LED technologies is more than, whether this is more than mu for SKS industry enterprise. So we want to test this value. So therefore the sales manager would like to test whether the average lead time for LED technology is longer than SKS enterprise by stating the hypothesis. So we are going to test whether the lead time for LED technologies is longer than SKS enterprise. If equal, then we will accept null hypothesis. If not equal or longer, we will accept alternative hypothesis. So now, first step is we need to state our hypothesis statement, right? So our hypothesis statement will be null hypothesis mu LED is equal to mu SKS. Alternative hypothesis will be mu LED is longer than mu SKS, means that the mean lead time for LED is longer than SKS. So we're going to use alpha equal to 0.05 as a significant level, right? Our test statistic will be t-test. We're going to use t-test, right? So now we'll open the file. Now we have file. So we are trying to use delivery lead time and the customer comparison. So other than the variable, we're going to hide the variable. So now, since we in the customer, we have sound, Sdn Bhd, sonic Sdn Bhd, superpower audio, and so on. So this is quite not in order. First step is we try to sort the customer. So we're going to focus on this part, LED and SKS customer name. So let me highlight LED first to be on blue color. SKS will be on green color, right? So now in this example, we are trying to assume that we have unequal sample. So now, if you still remember, we need to install add-on tool pack in the data set in the Excel. So once you already install the tool pack analysis add-in in Excel, we will found in the data tab, we will found data analysis. If you don't know how to install this, you can refer back to my previous video. I already show how to install a data analysis or tool pack analysis add-in. Alright, so we need to click on data analysis on the data tab, and will appear data analysis chat box, a dialog box. So we need to choose a t-test to sample assuming unequal variance. So if this data is having an equal variance, then we need to choose equal variance. But for now, in this data, we are choosing unequal variance and click OK. So this dialog box will appear. So now, first step for variable one range. So you just select delivery time for lead technologies, and for variable 2 range, you just highlight lead time for SKA and T-price lead time, right? And then for mean different, hypothesized mean different, we just put 0 because the hypothesis, our hypothesis, null hypothesis should be mu LED equal to mu SKS. This is also equal to mu LED minus mu SKS equal to 0. This is the manipulate one. So that's why the hypothesized mean should be equal to 0. And alpha we set as 0.05. And then for output option, we have output range, new worksheet ply, new workbook, right? So if we want to we want the result, Excel to display the result on the same worksheet, so we just click on output range and click on where the result should be appear. I say I want it to be appear on L9 column, right? And then I click OK. So now we can see here the Excel already give us the statistical calculation for variable 1 and variable 2, assuming unequal variance. This is a t-test. So they give us the mean value, variance, observation, how many observation we have. For variable number 1, which is LED technology, we have 12 observation. For SKS enterprise, we have 16 observation. The hypothesized mean difference is equal to 0. The degree of freedom is equal to 12. This is the T statistics. that Excel is already give to us. So this one, C statistics, should be equal to, what is the value here? 5.1360. 5.13609, right? So this is the Excel give us. So next is we need to specify our critical region. So our critical region, we need to refer to our alternate hypothesis. Since our alternate hypothesis is more than, it should be on the one-tail test on the right hand side. So the value of rejection region should be on the right hand side. So this is our rejection region, and this is our acceptance region, right? So the value here, the critical value here should be equal T 0.05 with degree of freedom. Our degree of freedom here is equal to 12, and this Excel is already provide us the critical value for one tail. So we're going to look here 1.782. So this one should be 1.782, right? So now we need to make our decision rule. Decision rule, if T statistics, means T, this is what we call as, let me change the color. This is what we call as T calculated, and this is what we call as T statistic. Right? If T statistic is more than T calculated, then H null is accepted. Means that the T calculated is on acceptance region. If T statistic is less than T calculated, means that T calculated should be on the rejection region, then H null is rejected. So our decision here, since T calculated is more than T statistic, means that in this case our T statistic is T calculated is 5.136 is more than T statistic, which is 1.782, then null hypothesis is rejected. So since the null hypothesis is rejected, we can conclude that the average lead time for LED technologies is more than lead time for SKS enterprise. So this is one way to make a conclusion for t-test. Another way, by looking at the p-value. So we can look at the p-value here is for one tail. P-value for one tail is 0.0012. So now our p-value is 0.0012. There are 3 zero actually. 0.00012. So our decision, if p-value is less than 0.05, which is our alpha, then null hypothesis is rejected. So our decision is, since p-value is less than 0.05, which is our alpha, then null hypothesis is rejected. So our conclusion would still remain here lah. The average lead time for LED technology is more than LED mean of lead time for SKS enterprise. So I think that's all for making two sample hypothesis tests using Excel. This is for independent sample, right? So next video I will show you how to calculate two sample tests for mean for paired sample. Okay, till then, Assalamualaikum warahmatullahi.